So after we go through the 6 steps, in this video, we're actually going to start to look at step 4.1, estimated regression sample model. Estimated regression sample model. So before we look at what kind of model we're going to estimate, we have to learn what kind of model going to look like. So that's why we're starting from looking at our populations models. So the simple linear regression model, so this is for the population. So let's say you got an opportunity to collect all the data for your population, and so you try to find the relationship between your x and y variable. In order to find this relationship, we have to use this model called the simple linear regression model. So how this model look like? So this model will connect your y variable, your dependent variable with your independent variable x. So the model will look like the following. So y equal to beta 0 plus beta 1x plus the epsilon. So the beta 0, beta 1, and epsilon, they are all Greek letter because we are talking about the population model. So what's the name for y? Yes, dependent variable. So it has to be quantitative data. So if you forgot, make sure you review the previous video. And x is my independent variable. So we're using the x variable to predict the y. So again, I use the size of coffee shop as example. So the y variable will be the size of coffee shop, and x will be let's see the budget you are planning. So you are using the budget plan to predict what kind of size of coffee shop you are looking for. Again, this is simple linear regression model. That's why you only can see one x variable. And so think about the content, the concept I asked you to review related to geometry class. So what's the name for beta 0? Yes, beta 0 is y-intercept. So that is when x equal to 0, the value for y. So basically, that is the intersection between the straight line and y-axis. So that's why it's called y-intercept. So what's the name for beta 1? Yes, it's called the slope. And so it's very important you remember those names because when you work on your homework, and you will be required to interpret your results. And one thing I forgot to mention at the beginning of this chapter, so for this chapter, we are emphasizing the Excel skill and interpretation. Because you're not a math major, I don't want you to show me how to use the giant formula to calculate the value for beta 0, beta 1. So instead, we try to use the computer to make our work efficient. And so most of your time you're going to do in the business world is after the software develop the result, you have to be able to interpret result. So it will be like the business analytics. So you got the result, you can use your professional knowledge you learn from your finance class, your business class to help to interpret result. So this class will build up the basic foundation to guide you, to let you understand what is the basic method to interpret result. So that's why this is second important part. You have to pay attention. That is how to interpret the result. So when we read the slides, and you will notice that actually every statistic we learn, I will also teach you how to interpret the result. So beta 0 is y-intercept, beta 1 is the slope, and during the whole semester, and you will notice that every homework I will ask you to interpret the slope, so which means you have to understand how to interpret the slope. And epsilon here is called a random variable, and it is an arrow term, so the arrow term. So later I will use a diagram to help you to understand what is this arrow term means. So this is called a simple linear regression model, y equal to beta 0 plus beta 1 x plus epsilon. And so the next model we're going to look at is related to the simple linear regression model, but we call it the simple linear regression equation. So the expected value of y equal to beta 0 plus beta 1 x. So actually this model look very similar like the previous one. So this equation look like the previous one, except the left hand side is no longer called y. Instead we call it expected value of y. And on the right hand side, we're missing one component, that is epsilon. So why is that? To help you to understand the relationship between the previous equation and this equation, I want to show you a diagram. But one thing before I show you the diagram, you have to keep in mind, so both equations are used for the population. So which means this is the model we try to estimate. We try to estimate ultimately. So what's the relationship between the first simple linear regression model and the second simple linear regression equation? Actually, you can very obviously to understand on this diagram. So actually, the first model, simple linear regression model, what we try to capturing you this equation is the scatters on your scatter diagram. And the second equation, expected value y equal to beta 0 plus beta 1 x. So this equation actually is to characterizing this line. So now you should be able to see where is the arrow term. So the arrow term actually is the differences between yi and expected y. So basically that is the distance from your scatter to the trend line. So you can see for this part is uncontrollable. So some of the observation have smaller epsilon, and some of the observation has the smaller epsilon. So that's why we call it the random variable. So this is the error term. So the reason we call it error term is because after we receive this regression equation, and if we try to predict this dot, it usually won't impossible because we have this error term exists, won't be able to estimate, won't be able to observe. So this is a relationship between the simple linear regression model, which will include this error term, and the simple linear regression equation. So this is this trend line. So this is related to the population. So in the reality is, we mentioned so many times at the beginning of the semester, so you won't be able to get opportunity to get all the value for the population. What we usually do is go to use the sample survey to select the sample, and then based on the sample data, we do the estimation. So that's why we have to understand relationship between the population model we learn here and the sample model we're going to look at pretty soon. So let's look at this whole estimation process. So this is our goal. We try to understand in the population how y and x variable are related. And so in order to understand this relationship, we try to estimate this population equation. So expected y value equal to beta 0 plus beta 1x. So after you collect the data, you will have the value for y and x, but you won't be able to know the value for beta 0 and beta 1. So which means if we will be able to obtain the value for beta 0, y-intercept, and the slope, we actually will be able to understand the relationship between x and y. So this is the goal. As I said, you won't be able to collect the data for the population. So what we're going to do is we actually going to rely on the sample. So we collect our sample data, and based on the sample data, we will be able to estimate this equation. So that is the second equation we're going to look at. Actually, when you work on your homework and work on your exam, we always starting from this equation instead of these two, because you won't be able to obtain the population data. You only can get your sample data, and you are estimating your sample model called the estimated regression equation. So look at different expression. Compare with the population model, the sample model, we are using English letter. So we are consistently using the same notation. So instead of using the Greek letter, we're using English letter. So the left hand side is y hat. So the hat in the statistic world usually means it is estimated. So the estimated y value equal to B0. We no longer use the Greek letter, we use the English letter B0. So this is my y-intercept plus B1. So this is my slope. Keep in mind, so I always ask you to interpret the B1. It's very important you know how to interpret the slope. We're actually going to learn later. And the times x. So basically they look very similar, except we are replacing all those Greek letter to my English letter. But this is the model you have to keep in mind. Actually, you should remember this model because you have to remember how the model look like, and then you can use the statistic result from the Excel to fill in this equation. So obviously, when you collect the sample data, you have the value for x, value for y, but you don't know it's B0 and B1. So that's why you are using the sample data, using the computer software to help you to estimate the value for B0, y-intercept, and B1 slope. So after you got your sample model, and then we're going to use the statistic test to see if B0 can be B0 and B1 can be a good estimate for beta 0 and beta 1. So if the answer is yes, and then which means your B0 and B1 can significantly represent in beta 0 and beta 1, and then this equation will be used to represent your population model. So this is the whole analysis procedure. So now let's look at our first step.